All right, scholars, in this video, we're going to be introducing the concept of compound interest. Compound interest is a continuous growth of investment over time, such as a bank account, the stock market, or an investment fund or funds. I like to think about compound interest in this kind of diagram. Let's say I take $200 and I invest it into a savings account, and it has a really good interest rate, 10%. So what's going to happen? After, the first year, it's going to take the $200 that I have in the bank or the savings account, and it's going to take 10% of that. Okay, and that's what is going to be called my interest. So interest rate is the percent. Interest is the result of the proportion from the amount I have in there. So I gain $20 from the interest of my money that I put in there for $200. Again, that's 10%. Now, compound interest just means it takes the interest and it compounds it or adds it to the amount I had originally. So these two amounts come together, compounds, give me a new amount. So 200 plus 200 plus 20 gives me 220. So now I have a new amount, and that compounding action occurs again. So maybe I hold that $220 in the bank account. At the end of the year, it takes 10% from there. So my new interest taken from my $220 is now $22. It's going to compound, so that $20 or $22 is going to add to my $220, giving me, again, a new amount. And that compounding action continues if I let the money sit in that savings account. This is the idea of compound interest, and that's how I like to view compound interest. There's this portion of, a percentage of the amount that I have in there is taken out, which we call interest. Then the compounding action means that the interest is added to the current amount, giving me a new amount. Okay. Now, this process can be very tedious if we did it by hand. It has that sequence kind of feel to it. So we can use a formula to kind of speed through it. Okay, and that's going to be what we're going to describe as compound interest formula. There's a lot of variables going on in this formula, exactly 5 of them right here. We're going to dissect each one of them, okay? So let's take a look. FV, that's your final amount, okay? That's going to be what the amount is going to be after a certain amount of years. PV is the starting amount, okay? R is the interest rate, how much percentage-wise is being taken out. N is the number of years, so how long am I, putting that money into the savings account. K is something that we need to talk about, because K is going to depend on, how many times that process of compounding is going to occur, in most cases, per year, okay? So are we compounding just one time a year? Are we compounding every month? That's going to change the K value. I have a nice little diagram at the bottom of our page to kind of help us. So if that compounding action occurs monthly, well, how many months are in a year? 12. So K is going to be 12. It's going to occur 12 times per year. If it's annually, it's just going to occur one time per year. Semi-annually, it's going to occur twice a year, so K is 2. And quarterly, think of how many quarters are in a dollar. There's 4. So quarterly just means it happens every quarter. That means it's going to happen 4 times. So now that we know what the formula looks like, let's see it in action. A lot of our problems are going to be word problems, because we're going to dissect the word problem and pull out the information that we're going to need. I like using this this table to organize what I need for the compound interest formula. Again, I need the final amount, the starting amount, my interest rate, how many times I'm compounding, and the number of years. In all these problems, what they're going to do is they're going to give you 4 out of the 5 pieces of variables that we have. You're going to find that 5th variable, okay? So just keep that in mind. A lot of these problems will give you enough information to have 4 out of the 5, and you got to find that 5th one. In these beginning ones, I want you to find the final value or the final amount in the word problem. So if we look at this one, what will be the value of Jessica's mutual fund after 10 years of initially investing $5,000 with an annual interest rate of 7% compounded monthly? So we got to dissect that. I color-coded it to help us a little bit visualize how we're going to pull it. So let's see. We have Jessica has a mutual fund. We're trying to figure out the value of her fund after 10 years. So N is going to be 10. Usually when you see years or some type of time, that's going to be your N value. If you see the word initially or start or deposits, that's usually going to be our PV. How much did she start in her account, or in this case, the mutual fund? $5,000. R is the annual interest rate. A lot of times you're going to find the number right before the percentage. So her annual interest rate is 7%. The one that's going to be the trickiest, again, is going to be that K value. How many times is it compounding? In this case, it's compounding monthly. There's 12 months in a year, so K is going to be 12 because it's going to occur 12 times per year. So now that we have the table, we can look at the actual calculation process. Here's our formula right here. I have FV, PV, I have my R, K, and N. I have labeled everything using this table, so great, now I just need to fill it in. PV is 5,000. My R value is 7. Again, 7% is my annual interest rate. K, how many times is it compounding? 12. The K is going to have two places, okay? With the 100 in the denominator and also in the exponent position up on top. Then we just need the number of years. Okay, so taking this formula, I filled in what I know, and now I can grab my calculator. So let's grab our calculator and plug that into it. The initial amount, 5,000, times 1 plus interest rate 7 over 100. Don't forget the K value, 12. And then I'm going to raise to the power of, again, it's going to occur 12 times, the compounding, right? It's going to occur every month, times 10 years. That's going to give me a value that I've written right here. But because we're dealing with numbers, we're going to round, okay? We're not going to have a bunch of decimals. So we're going to take this amount and we're going to round it to 2 decimals. So here's the decimal. 2 places after is that 0. So I'm going to round this 0. It's going to depend on the number on the right, in this case 6. That means we're going to round this 0 to 1. And then we're going to drop everything else. So if we look at it, Jessica's mutual fund will have about $10,048.31 after 10 years of her investment. Remember, she invested $5,000. She's going to have about $10,000 after 10 years. She's essentially doubled her money using compound interest. Again, you could have done that long process by doing this kind of idea, but we have a formula to help us. Okay. Now I want you guys to practice with a few problems using this concept of compound interest, finding the final value. If you have any questions, please reach out to me. Otherwise, I'll see you in the next video. Bye, guys.